All right, good morning, 8th grade. Here we go. We're going to start talking about more linear equations. This is nice because we already kind of know how to do it. We have a set of two or more linear equations in the same variables. One example is shown below. We have an equation number 1 and equation number 2. Now notice there are there are going to be two separate lines. This one is has no slope, or it's 1 over 1, so it's a 45-degree angle, goes straight up. This one's 2 over 1, so it's going to go up a little bit steeper, and it's going to cross it's going to cross the vertical y-intercept at two different spots. So notice we're going to have two different equations on the same graph. So we're going to start looking at, looks like more data-driven type stuff. So a solution of a system of linear equations in the two variables is an ordered pair that is a solution of each equation in the system. So remember my line there, I showed us that that they cross at a certain point. That is what we're going for. We're going for a solution. They are not parallel, so at some point they will cross. So I guess that's what we're going for here. And here we are, example number 1. It's showing us exactly what I was talking about. We have two lines. One has a negative slope, yep, right there. And one of them has a positive slope, so they cross at one point. Then they're showing us they're just showing us the solution. So they worked it out. I don't know if they graphed it. Graph each equation. So they graphed it, and then they estimated the point, which is pretty close there. It looks like it's 3, -1. So they've got this, there's -1 for the x and 3 for the y. And they ran it through both equations, and it shows that 3 is equal to 3. That's a good sign that it works. All right. Now they're going to talk about real-life application in terms of, it looks like estimating or kicker on a football team scores 1 point for making an extra point and 3 points for making a field goal. This is the kind of information that coaches use. They have somebody crunch the numbers for them, and then they use it when they ask somebody to do something sometimes. Not every coach is quite that way, but that's what this is for. Probably more major leagues. They have people crunching these numbers. The kicker makes a total of 8 extra points and field goals in a game and scores 12 points. Write and solve a system of linear equations to find the x of extra points and the number of y field goals. So we're using a verbal model to figure it out. We have number of extra points, number of field goals, number of kicks. So we have extra points times number of extra points plus points per field goal, number of goals y, total number of points. So the system is standard form. They don't have a non-standard form. So we have two different things here. If you notice, we have number of extra points, x, and number of field goals, y. So a kicker team scores 1 point for making an extra point and 3 points for making extra field goals. So we said x is for extra points and y is for field goals. So x plus y equals, the kicker makes a total of 8 extra points. So we don't know what the x and the y are. But then in the second one, where are we coming up with this 3y equals 12? And extra points, goals in the game, and scores 12 points. Write and solve. So 3 points for making a field goal. And, that's where they're getting it. There are 3 points for making a field goal. And then in this linear equation, find the number of x where the field goals in a game scored were 12. So 3 points for the field goal, y equals field goal, so 3y, that's why they got this. And the games, they scored 12 points, and there's this. So there's 1 point for making an extra point, and 3 points for making a field goal. All right, so there it is. Kind of confusing, but there it is. Graphed it. You can check your answers with Desmos, and it should come out like that. That's what calculator will use. Okay. On to the assignment. That was fast, I know, but fortunately I don't think we're going to have to find all of this too much. All right, so starting on number 4, use a table to find the break-even point. Check your solution. So, use a table. All right, this is my third try at this. It isn't too hard, it's just that I wanted to do it with graphing, and this says use a table, and I didn't want to use a table. So this is way better if you use a table, though. It's just going to be easier. So you've got two functions. You've got so your table looks like this. You've got this long line going out this way, long line going out this way, and you've got a box for your C and a box for your R. So C here and R here, and then we're going to figure out at what point do they equal the same amount. So each one of these points up here equals x. This is shown in the exercises in the beginning of the chapter. So this is the closest thing I could find to a table. So here we go. Let's just make it really quick. If x equals 0, and we have 1, 2, 3, 4, and then 5. Should be able to find it. That's how far it goes anyways. Undo that last one. It looks like a 6. There you go, 5. If x equals 0, then on the R it's going to be 0. On this one it's going to be 150. And then we have well, then we go 1. If x equals 1, then this is 45, and 15 plus that is 165. So you just keep working that up until you figure out when you get to the right answer. The next one would be 2. 2 times 45 is 90, and 2 times 15 is 30, and then that makes that 180. And then the next one, etc. I think you can figure this out. It's actually pretty easy. Not too bad at all. So you're going to do that same thing for each one of these problems and just run it through the equation. And in day 2, we're going to be looking at the rest of these problems, which should, in fact, start correlating with examples 1 and 2. We have 7 to 19 here. I'm going to just go ahead and do, and it's odds, or 7 to 15 odd, depends on what we're doing. I'll start with 7, and it says match the system of linear equations with the corresponding graph. This is actually quite easy because we've got slopes and y-intercepts and all that cool stuff, right? So we have a y-intercept here of -2 and a y-intercept of 13. So I'm going to look at these and see where do I have a -2 intercept. 2, 4, I don't have a -2 intercept. Do I? Anywhere? Let's see. I'm looking and I don't see it. Look closer. Negative. And, well, let's see. What about 13? Can I find a 13? Oh, here's a 13. Is there a 13 on any of the other ones? There isn't. So is this kind of -2? I guess it kind of is, isn't it? And then its slope is it's a -1. So not perfectly straight, but it's kind of straight through, right? All right, and then I guess that would be B. So number 7 is B. So that means number 9 has to be C or A. And you would look for your slope here. We got my intercept. I have a -3 and a +5. So I'll let you figure that out. Onward. Number 11, you're going to solve the system of linear equation by graphing. So this one, you're going to make a graph on number 11, just like example number 1, and it shouldn't be too hard. It looks like this one's a little bit, oh, this one's not too hard, because both of these cross at a nice spot, and so neither of them are going to have halfway in between crossing. So you should be able to graph it pretty easy. Remember, this is where your y-intercept is on both of those. So you're going to do a full quadrant coordinate plane. You're going to count by ones. And I'm just going to mark my y-intercepts just so you remember how to do that. And then I'll start with the slope. But anyways, all right, so my first one up here has a -4. So 1, 2, 3. I'm going to put it right here in red. 1, 2, 3, 4. So it's going to be right there. And then for the -4 one, this one right here, the slope is -1. So it's going to go downhill. It's going to go over 1, down 1, over 1, down 1. Or yeah, it can go over this way 1 and down 1 here, over 1, down 1, over 1, down 1. So it's going to be a diagonal, perfectly diagonal, going to go like this, more or less. And then +4 starts up here, 1, 2, 3, 4. I'm going to use blue there. And then it has a different one entirely. It goes up 3 and over 5, or it goes down 3 and backwards 5. So it goes 1, 2, because my point here is to cross my line, right? And then it goes over 1, 2, 3, 4, 5. So that means it's going to connect right about here. And then I'm going to draw my line, and I'm going to let you go from there. Then you need to do 13 and 17 on your own. I don't know how they're example 2 instead of example 1. Let's take a... All right. This then, I guess it's not perfect, but it kind of comes right here, which is over this, which means it's -4. Your solution is -4. And this is, I don't know, it's going to be 2 maybe. It's close to 2. Let's go ahead and call it 2. You could run those through and see if it comes out close, but really check with Desmos. Use your Desmos again, your Desmos app. And just put in these two equations here, and you should come out with the right answer, or it should come out really close, or anyways, it'll be right. Then what you can do is you select the dot or select the point where the two lines intersect in Desmos, and that'll give you the actual coordinates there for solution. And this, let me think here, let me check if that's the answer on that. Sorry for the pause. Number 11 is, oh, it's wrong. It's actually, yeah, it's wrong. I graphed it right, but it's wrong. My graph isn't accurate enough. So it needs to have a complete squares to make it more accurate. So check in Desmos, it'll be more accurate for you. But if you're using graph paper, it'll be more accurate for you. So use your graphing paper for these problems, because otherwise you're going to have a hard time doing it. So it comes out even numbers. So if you've graphed it properly, it should come out just fine. Not a problem at all. There's no fractions for the solution on number 11. Or 13 and 15. They all come out with nice even numbers. They solve really nicely. If you look at I'm looking at number 14 and number 13 and number 15. Those ones are a little more difficult because they give you the standard form on top. So, or they're just giving you equations instead of, no, they give you line slope too, but you have the equations. So you might have to figure that one out a little differently, or solve the first equation so that it equals. So I'll go ahead and do this 13 instead of talking my breath off. All right, so I have x plus y equals 27. So notice this is not line slope, but the next one is where it has a line, or y, and an intercept, and the intercept and slope. So that makes it easier on that one. In solution on the next on it, I would do this. I would turn this into a linear equation, which really just involves moving the x over. So I'm going to rewrite this one down here. I subtract x from this side and subtract x from this side. So I have y equals -x plus 27. So now then I have my graphing equation here. And And that's pretty much it. And then you can start running out. This is way high, so for your intercept. So you may want to go by 3s for your y and go by 3s for your x maybe. Entirely up to you. So that means, this is 3, 6, 9, 12, etc. Does that make sense? So that you can get there faster, 3, 6, 9, and you can find your intercept. Good luck with that one. Okay. All right, for the second part of day 1's exercises, our review, we're solving equations, we're checking your solutions. It doesn't give us an answer for C, but really we should remember that when we're adding fractions there, they can come out just fine. We're just y on both sides. You just need to combine all of these things. This one you're going to distribute. 3 times x is 3x, and 3 times 8, and then add all your like terms together. 6x, and anything with x on it can be combined, added, or subtracted. Same thing for 26, and same, well, here you are on 25. You got 3/4 plus 1/4 equals 1. We're subtracting, actually, so it'd be 1/2 c equals 3. So we would multiply everything by 2. We multiply everything by 2. So let's see here. I got 3/4. First thing we do is we write down the original problem, minus 1/4 c plus 3 equals 7. So I can subtract 3 from both sides, really, to be done with that right away. Then we would, let's do this one as we go down. So 3/4 minus 1/4, I would 1/2 c equals, and then I've got my 4 over here because 7 minus 3 is 4. Now, to get rid of my half, I multiply by 2 over 1, because when I cross these out, I'm left with 1 over 1, which equals 1. And then I have to do the same thing on this side. I have to multiply by 2 over 1, or just 2. And that would give me my answer. C equals, etc. Okay. I'm going to remind you about the distributive property. This applies to both 26 and 27. You should remember this, but I'm just going to remind you. All right, 5 times 2 minus y equals plus y, or not equals, but plus y equals -6. Okay, distributive property. That means I take this 5 and I distribute it into these parentheses here, because I can't subtract y from 2 since I don't know what y is. But I can distribute the 5 in, which gives me 10, because 5 times 2 is 10, minus 5y, oops, not 6, 56, it's 5y, plus y equals -6. Now I can combine like terms. 10 is a like term to the 6, so I can subtract it from both sides, subtract 10 from both sides, which makes this become -16. Okay, so that's going to be my equals there. -5y minus a y, or plus a y, that means I'm on a negative side right now, so I'm going to go towards my 0, 1, so that gives me 4y, because this is a plus 1y, it's not just y, it's a plus 1y. So I have 4y. When I've combined these two, I get 4y. And 4y equals -16. All right, so I'm going to divide by 4 and divide by 4, which leaves me with a y, and then you reduce the fraction all the way. So similarly, you're going to do the same thing with 27. Get x all by itself, and what is the slope of the line that passes through these two lines? Oh, you can do this. Maybe I would suggest that you graph it, or you use your, this is for 27, right? 27. This is a reminder. Put this in your folder, or this should be in your math binder, math notebook journal. M equals y2 minus y1 over, this is your rise, because y goes up and down, that's rise, x2 minus x1. So in this, we have an x1 and an x2. I'm just going to pick this one right here as my 1, and this as my 2, because it really doesn't matter. You could do it in either order. The important thing is that these came out of the same box and these came out of the same box or ordered pair. That is what's important, okay? So when I write it out, I'm just going to help you out. I'll start by writing in the first ordered pair, or I'll write in the top for us. So this should equal, I'll go sideways here because I can, y2 is -1, and then I'm going to subtract, and I'm going to do parentheses because it's 2 negatives in a row. It's -2. So this is something you need to remember here. When there's 2 of them in a row, -1 times -2 is going to be a +2, right? So I will just go ahead and rewrite this as a +2, -1 plus 2, and then I guess I'll keep going because I'm afraid somebody will forget how to do this and stuck for the rest of the day. I don't know. Anyways, this is 3 because that's my x2, right? I'm using my x2, and minus my x1, which is again is a -2, so that turns this into just a +2. And then you just do the math there, and you should come up with the proper answer. Have fun with that. Now I'm going to move on to day 2. Oh boy, this is cool. It says use a graphing calculator. So I'm going to let you use a graphing calculator so you don't have to use those. You're just going to use Desmos as before, and then you're going to find, to solve the system of linear equations, so you're going to find the intercept. Remember I told you, you put in these coordinates, and then once you've put those coordinates in, you find where the 2 lines intersect. You select or push your pencil or your pen in that one spot right there, and then it will give you the coordinates for the solution. So do that for both 19 and 17. So those are going to be easy. All right, number 20, describing an error. The solution of it is y equals 0.5x plus 1, and y equals -x plus 7 is x equals 4. Does x equal, what if x equals 4? So just throw x in there. Describe and correct the error in solving the system here. So we're going to just throw 4 in there. So we've got the couple of anyways, we got the things here. So we're going to write it in. I'm going to write in the first equation, and we're going to do it in red so we can keep everything together. So y equals 0.5 times 4 plus 1. Put the 4 in parentheses to show it's there, and then the other one is y equals -4, no parentheses needed because it's just a sign there, and 7. So -4 plus 7, y equals 3. And what about here? 5 times 4, 0.5 times 4 is 2, right? So 2 plus 1 is 5. So y for the red, or the y, equals 3. It's the solution. So it's a solution for both of them. So on both of them, y equals 3, so it should be, okay, so then we need to solve for x, right? So if we put y in either one of these, we should get our correct solution. Why did they graph it wrong? Let's see what they did wrong. This one here should be crossing at, should be going negative from 7, so there's that. It's blue. This one should be starting at 1, it is, and going up 0.5 each time. So it's going up 0.5 each time. It's going up. The solution of the linear system. So they're saying, is this a solution? Or, well, x does equal 4. It does work when x equals 4. And it works if x equals 4 on each one, but y is going to equal 3, correct? So the real solution here is actually going to be 4, 3, and that would be the proper solution. So I think that's where the mistake is. They wrote they wrote the solution for x instead of the coordinate, the solution, the actual solution. 22, 21. Is it possible for a system of two linear equations to have exactly two solutions? Can it have two solutions? Or straight lines, will they cross more than once? If it has two solutions, it would have to cross more than once. And let's see the last one, 23. You and your friend are in a canoe race. Your friend is half a mile in front of you and paddling 3 miles per hour. You're paddling 3.4 miles per hour. At what point will you pass them? You are 8.5 miles from the finish line. How long will it take you to catch up to your friend? You both maintain your paddling rate for the remainder of the race. How far ahead of your friend will you be when you cross the finish line? So we're going to set this up. I wish I had a worked out solution thing to help me with this one. So what we have, let's see, you're paddling at 3 miles per hour. So, all right, the book shows one way of problem solving. Basically, they're using a chart. So in the chart, you have time, and you have your distance, and then I'll just do D, and then this is your friends, apostrophe S, because it's ownership, friends, use a proper cursive thing here, friends, distance, D-I-S, oh, I'm just right, I was just using a capital letter, so just use a D. Then we have our graph coming straight down, and sorry, not perfect. Doesn't have the cool notability snaps, which is nice. All right, so at first everybody starts with 0, and then at the rate here is per mile, right? You and your friends are paddling. You have 3 miles per hour. You're paddling at 3.4 miles per hour. So, let's see, they did 0.5 hours, 1 hour, 2, or 1.5, 2, or 3, 2.0, wow, write that in again. They're going by half hours. So, as you write that in, 1.5, 1.0, 1.5, 2.0, 2.5, 3.0. And we were talking, it has, where does it say? You have 3 miles. How far does it go? It doesn't even go that far. So I know I will be, if I'm going at 3.4 miles per hour, I'm going to be right here at 3.4, right? And my friend, your friend is a half a mile in front of me, right? So he actually is at 0.5. And he's going at 3 miles per hour. So every hour he's going 3 miles, right? Yeah. So he would be 0.5. This would be 3.5 because I would add my first point there to 3.5. And then somewhere in between here, we're going to pass him, correct? So 3.5, and then at 1.5, so we have to do a little bit of math here. What's half of 3.4? Isn't that, it's 1.7, right? 1.7. So if I add 1.7 to 3.4, that gives me my next distance. 3.5, 0.5 to 3.5. Oh, this one's easier because he's going 3 miles an hour. So in he's going to add 1.5 to his time, right? So at half hour, he's going to be at 2 miles, and then I'm going to add, each time I'm adding plus 1.5 for the friend, and for your time, each time you're adding 1.7. So I think you can figure this out. All right, now that I've done that, that was easier. That was harder than I thought it would, or easier than I thought it would be. All right, good luck, have fun.